4 different ways that can look, but the end behavior is what's going on to the far left of the graph and what is going on to the far right of the graph. And there are 4 different possibilities. And so those possibilities are based on the degree, which is just the highest power of your variable that you've got in your polynomial, and whatever the leading coefficient is. So if we had our polynomial written out in standard form, is that first term going to be positive or negative? That's what all of this end behavior is based on. And this is going to match up with stuff that we've done in the past with lines, with quadratics. It's not going to be anything crazy. We just haven't graphed any polynomials. So I have this lovely little tiny chart here that I will give you guys on any of the tests or quizzes, so you won't have to memorize this. You're just going to have to determine what you're looking at in the actual problem you have for which of the end behaviors to pick. So there's 4 different things that can happen. I'm just going to give you like the most basic version of each of the possible options. So hopefully these will be things you're not going to be like, what is this? But these are all things you've graphed before. Okay, so positive just means the leading coefficient has a positive number in front of it. So I just wrote basic y equals x. So this would just be 1x. You're not going to see the 1 written in front of it, but 1x, so that's positive. And then the exponent, which you're also not going to see written normally, would just be x to the first. So positive because I would have 1 as the coefficient, and it's odd because it's just a plain x by itself, x to the first power. So if you just thought like mx plus b, right? Y equals mx plus b, this would start at the origin, and you would just go like up 1 over 1, up 1 over 1. I'm just going to sketch a picture. This would be like a perfect, if I did a good job drawing this would be a perfect diagonal right through the first and third quadrants on the graph. So that's a positive odd function, just as an example. Okay, so it's a line with a positive slope is what it looks like. Now I'm going to draw on this. So what we call the end behavior, you guys can see the far left. So to the far left of the graph, that's pointed down. So the end behavior over there goes to negative infinity. And to the far right, the end behavior, that rest of that graph is pointed up. So the rest of that graph would go up to positive infinity. So my end behavior, that's what I have on the little graph over here. So this would be positive and odd. So it goes down at the beginning of the graph, or down on the left side, and then up on the right side of the graph. That's what that little summary is there to the side. Okay, if I do, this is the most basic negative odd that I could think of. So you see I have a little negative in front of the x, and then this is, again, it's odd because it's x to the first power. If it was to the third or to the fifth or to the seventh, these would all match in terms of their end behavior. But just a basic graph, if I had y equals negative x, again, you'd start that at 0, 0, but you would go down 1 over 1. So this is actually a perfect diagonal through the second and fourth quadrants if you were looking at a graph. So if we've got an odd degree, the end behavior on the far left, you can see this is the opposite of what I just drew. So this type, on the far left, you actually go up to positive infinity on the left side of the graph, and the right side is going down to negative infinity. Whenever you have an odd function, the end behavior is opposite directions. One side's going to go up and one side's going to go down. So you'll just have to look at the equation to figure out which one of those end behaviors you want to pick. Now, even functions would be like my highest power is 2, 4, 6, 8. We're not going to have anything that big, I don't think. But what I put as the most basic would just be a little quadratic. So it's just y equals x squared. So hopefully you guys, we're not plotting specific points or anything, but that would have its vertex at the origin, and that would just make a little parabola. If you have an even function, so like I said, x squared, x to the fourth, x to the sixth, both ends point the same direction. If that's positive, which this is just a plain x squared, there would just be like a little positive 1 in front of it if you wanted to think about it like that. But both ends, the left side and the right side, both go up to positive infinity. Whenever you have an even function, the end behavior is either both going to go up, or the next one it's both going to go down. So negative x squared, this would be negative, and even for my even exponent there, that would be a parabola, start at 0, 0. And again, I'm not plotting specific points, I'm just trying to give you guys a sketch to show you the end behavior. The ends of an even function both go the same way. If it's negative, both ends of this are going to point down to negative infinity. Is anybody those are the only 4 possible things that can happen. Is anybody having a question? Okay, now, most of these are in factored form. The reason they're in factored form is to help you see the zeros faster. The one thing that's tricky about this, though, I need to figure out what the first term would be if I put this lovely polynomial, this is in factored form. If I multiplied that all out, which I'm not asking you to do, but if I multiplied that all out, can anybody tell me what the first term would be in standard form? If we sat here and did like we did yesterday, multiplied this whole thing out, can anybody tell me what the first term would be? Yes, okay, how'd you get that? Exactly. If you guys if you have this factored form, the highest power is going to be literally like the first term in each of those factors multiplied together. There's nothing that's going to cause that to be negative. It would be x times x times x, so it would be x cubed. Okay, now, here's the deal. There's nothing making this negative, right? This would have a little positive 1 in front of it. So this is positive, and because my exponent is a 3, the exponent is where you get the odd or even. This is odd. All right, so my graph is positive and odd. So I can just follow the end behavior. Positive odd would follow the end behavior of the slope of a line that's got a positive slope. So it would just look like that. It's going to go down on the left side, up on the right side. So I'm just going to jot that down. Now, I'm going to draw the end behavior on the graph, but before I do that, I'm going to use those factors to figure out what the zeros would be. So if I can figure out the zeros, those are the places we're going to touch the x-axis. So if I've got x minus 5, x minus 1, x plus 2, what are my zeros for that? Joe, what do you think? Yes, okay, so 5, 1, and negative 2. Those are the zeros. So those x values, I'm just going to come and plot on the x-axis. So I've got a negative 2, I've got a 1, and I'm just making a little dot. So those are the zeros. That's where the graph will interact with the x-axis. Now, you'll notice my y-axis is not labeled other than to say it's y. We're not plotting specific points other than the zeros. We're just going to do a sketch of each of these graphs. So what I'm interested in, did you do the correct end behavior, which I've got that drawn, I'll show you in a second, and then do you have the correct zeros? So this is what I'm looking for. If you use your end behavior, whatever's on the far left, whatever 0, for this one it's negative 2, I'm going to draw the beginning of the graph should go down. So I'm just going to draw down on that. And the end of the graph on the far right, which is going to be, for this example, it's going to be on 5, I'm going to draw up on this. Now, all you have to do, and it doesn't have to be perfect, I'm just going to make like a wave through these zeros. So I'm going to go through the x-axis at negative 2, but I'm going to come back down and go through the x-axis at 1. Then I'm going to go through the x-axis, and I know I have to come back up to go through the 5. So again, I don't have the y-axis labeled at all. This is just a sketch. Doesn't have to be perfect, but I'm going to look for something like that. Does the end behavior go the correct direction, and do you have the correct zeros? It's just a sketch. Is anybody having a question at the moment? Okay. Let me look at this next one. So if I multiplied this all out, I've got negative x, I've got x minus 3, and I've got x plus 3. Can anybody tell me if we multiplied that out, put it in standard form, what would the first term be? If we multiplied it all out. Yes, so I've got this little negative, so this would be negative x times x times x would be negative x cubed. That would be the highest power we would have. So that little negative makes this negative, and the 3 is going to make that an odd function. Okay, now for my end behavior, odd always goes opposite directions. If it's negative and odd, it's going to kind of mimic the slope of a line that's got a negative slope. So it should go up at the beginning and down at the end. It's going to be the opposite of what we just did. So what would my zeros be for this example? Yeah. 0, negative 3, and positive 3. So I'm just going to go put those 3 guys on the x-axis. So 1 at negative 3, 1 at 0, 1 at 3. Use your end behavior to help you. So on the far left, it should go up on that side of the graph towards positive infinity. So that side go up. And then on the far right, whatever 0 is there, it's going to be 3 for this example. That should draw down. And then I just call this like making a wave. You're just gonna literally like wave through the x-axis. So I'm gonna go through at the -3, but I gotta come back up because I gotta go through the origin, and go through the origin, but I gotta come back down to go through the 3. So the shape of the graph would look something like that. We're just sketching it. It doesn't have to be perfect. If your curve is a little higher or lower than mine, that's fine. We're just doing a general sketch for these. Does anybody have any question? Okay. What would if I multiplied this guy all out, I've got x, x minus 3, x plus 2, and x minus 5. What would the leading term be for that one? This would be x to the 4th. You've got 4 x's. Nothing is making that negative, so this is positive, and x to the 4th, the 4 is what makes this even, that highest exponent. Now, what would my zeros be for this example? Like, where are we going to go with the x-axis? Ella, what do you think? 0, 3, -2, and 5. So we're just going to put dots on those places on the x-axis. So -2, 0, 3, and 5. Oh my gosh, I wrote positive even and then I didn't write the end behavior. Okay, if you have an even degree, then both ends are going to point the same direction. If it's positive, both ends are going to go up. So when I draw this, just whatever's on the far left, we're going to go draw up to positive infinity. Whatever's on the far right, it'll be 5 for this example. It'll go up to positive infinity as well. And then we're just literally going to wave through this x-axis. I'm going to go through the -2, but I got to come back up through the origin. I'm going to come back down through the 3, and then I got to come back up through the 5. So something like that. Doesn't have to be perfect. Just try and make it a little bit of a curve as you draw it. Shouldn't come to a point or anything like that. Does anybody have a question? Okay, I have one more, and then we're going to deal with how a multiplicity affects a graph on the back. So I've got -x, I've got 2x plus 5, x minus 4, and x minus 2. If we multiplied that out, what would the first term be in standard form? Okay. Yeah, you got a 2 in here, you got a negative, this is -2, you got x 1, 2, 3, 4, so -2x to the 4th. So this is negative because of the -2. It is an even degree because of the x to the 4th will be the highest power. So even goes the same direction. If it's negative, they're both going to go down for the end behavior. So on the far left, we're going to go down to negative infinity, far right, down to negative infinity. Okay, now my zeros, just that -x would be 0. What would it be for 2x plus 5? What would that give me as my 0? Okay, -5 over 2. Now, I don't know about you guys, but like I see that fraction, I'm like, okay, how do I graph that? I usually just change it to a decimal real quick. That helps me think about it a little bit easier. So -5 over 2, if you actually divide that on your calculator, it's -2.5. And so if it's not a nice number, just do your best to kind of estimate where that would be on the graph. I'm just going to do my best to go right in between the -3 and the -2. All right, then I'm also going to go through 4 and 2. So there's all my zeros. So like I said, the -2.5, just do your best to kind of come right in between the -2 and the -3. It doesn't have to be perfect. We're going to have 0, we're going to have 2, and we're going to have 4. Now, I know on the far left, which is that -2.5, I should be drawn down to negative infinity. On the far right, I should also be drawn down to negative infinity. And I'm just going to make like a little wave go through here. You're going to go through the -2.5. You got to come back down through the origin, go through the x-axis. You're going to come back up through the 2, and then you got to come back down through the 4. So just a sketch. It doesn't have to be perfect. It doesn't have to match mine exactly in terms of like how high those curves are or anything like that. I'm looking for, do you have the correct zeros and do you have the correct end behavior? Is anybody having a question? It would if we were plotting specific points, basically that would be a stretch. It would make it more narrow, but don't worry about, it's just really, it really is, the concern is it positive or negative? So don't worry about stretches and shrinks on these. We're just doing a sketch, but that's a really good question. So if you do get a number, like we had -2x to the 4th there, completely fine. to just sketch like we were doing all the others. I'm really just concerned whether that's positive or negative. Really good question. Anybody else having a question? Okay. Now, I have not given you any multiplicities other than just all of these were just a factor that was maybe to the first, which we don't usually write in there. But if you do have a multiplicity, so if you have an exponent on a set of parentheses, or if you have an x out in front, maybe I have an x squared or an x cubed out in front of my factors, then you got to have a little thought about what that multiplicity does on a graph. Okay, so there's two things. It could either be even or odd. So if your exponent for your multiplicity, if it's even, what it does is we call this, it creates a bounce. And what that means is it does not go through the x-axis. If you have an even multiplicity, you're going to touch the graph at that 0, but it does not go through the x-axis. It basically just, I call it like it bounces back where it came from. So if you want to, basically bounces off the x-axis is what it looks like on the graph. So I'm just going to make something up. Let's say I had y equals, I don't know, x minus 2, and that was squared. That would just be a parabola, but I'm just going to show you guys what this would look like. So at positive 2, I would touch the x-axis, but I would bounce back the direction I came from. So I'm just going to sketch on this little tiny graph here. I'm just going to go over 2 spots, but the end behavior would be up, up, because that would just be x squared. But I'm not going to go through the x-axis, I'm going to bounce. So it kind of looks like a little parabola when it touches. If it's a bounce, it just curves back and goes back, touches the x-axis, and then bounces back the direction that it came. If you have an odd multiplicity, all the ones we did on the front were odd, it goes through the x-axis. So for example, if I had, I don't know, I'm going to make something up. Let's say I had x plus 1, and that was to the 3rd power. So that would have a multiplicity of 3. So that would go like at -1 would be my 0. And this looks a little, if it's a 3rd power, it's almost kind of like the top of a parabola and then the bottom of a parabola. So it's not exactly a straight line. It's kind of like a curve. And that would be going through the x-axis. All the ones we did on the front were just exponent was 1, and so it goes through. If it's like a 3 or a 5 or a 7 or something like that, it's going to go through the x-axis also for 1. If it's even, like 2, 4, 6, 8, then it's going to bounce. So we're going to, all the ones on the back are going to have some kind of a bounce on the graph. Okay, so this very first one, and this is a little tricky. If I multiplied this out, I've got x plus 1 squared and I've got x plus 4 to the 3rd. What would the leading coefficient be if we multiplied all that out? Or what would the leading term be if I multiplied that out? It's not x squared. It's super tricky. What do you think? Yes, x. How'd you get x to the 5th? Exactly. Okay. So I didn't write this out here, but this don't write this out if this makes sense to you. But that x plus 1 is squared. So really that would be like us writing that out twice, and then that x plus 4 is to the 3rd. So it would really be like us writing that out 3 times. So if we actually went all the way down through that to multiply that all out, it would be x to the 5th. Does that make sense? Okay, so you can, if you want, just add the exponents. Like if this is squared and this is to the 3rd, I know I'm going to get x squared out of this and x to the 3rd out of this, so it's x to the 5th. If you want to just add the exponents, you don't have to write that out or anything. But in that case, this is positive and this is odd. So positive odd goes down at the beginning and up at the end for its end behavior, just like the slope of a line, or it's the positive, it's a linear, it looks like a line with a positive slope. That's what I meant to say. Now, this is a little weird. I only have 2 zeros on this. So -1 and -4. Now, if my multiplicity, so my exponent is even, we'll have a bounce. So at the -1, that's squared. So I don't want to go through the x-axis at the -1. That will bounce. X plus 4 is to the third. That will go through. So when I put these on the graph, I'm going to have a -1 and a -4. And you don't have to do this, but I always do for myself. If I know I have an even multiplicity like I do in this question, I just circle that one. So I remind myself, like, don't go through the x-axis at this point. I'm going to bounce back the direction that I came. Okay, when you guys do these, a lot of times if you put the end behavior in, it's going to kind of force you to draw the graph correctly. So I'm just going to draw in the end behavior. So I should go down on the far left and up on the far right. Now, based on my zeros that I've got in my equation there and my factors, the x plus 4, I should go through the x-axis at the -4, but I have to come back down. I'm going to try to kind of turn this into like looking like a little bit of a vertex of a parabola there. It doesn't have to be perfect, but I'm going to come down. I'm going to touch the -1. I've already got the end behavior in there, so it's got my graph kind of connected up for me, but basically that bounces back and then would go to positive infinity on the right. So putting the end behavior in can kind of help you kind of make sure you sketch it right. And then if it doesn't look right, you know maybe you made a mistake. Yes, ma'am. So this has an even exponent. If your multiplicity, so the multiplicity here is 2. If that's an even number, that's a bounce. The other one though, this is to the third. So the multiplicity on that would be 3. If it's odd, it goes through. So at the -4, I'm going to go through, but at the -1, that was even. So it creates like a parabola, basically, is what it does. Like the vertex of a parabola. It's going to bounce back the direction it came from. This is a little tricky until you guys get used to it. So let's just try another one here. Okay, if I multiplied this, I've got x squared and then x minus 4, x plus 3. If I multiplied that all out, what would the first term be? Okay. Yes, x to the 4th. Okay, so this is positive, and this guy is even, right? Because it's x to the 4th. That's for my end behavior, the degree, and then whether that leading term is positive or negative. So even goes the same direction. If it's positive, both ends are going to go up. Now, here are my zeros. I've got x squared, so just 0. I've got x minus 4, so 4, x plus 3, so -3. Do I have a bounce on any of these? Yes, which one? The 0. I know that's super weird, but this is squared. So that has an even multiplicity. So this would be like 0 multiplicity 2. If that's even, that creates a bounce. So when I plot these guys on the graph, I'm going to put a point at -3 on my x-axis, 0, and +4. If you want to use this, you can. It just helps me. I'm just going to circle the 0 so I know, okay, I got to bounce there. So I don't go through the x-axis. I'm going to bounce back whichever direction I came from. So I'm going to put the end behavior in. On the far left, I'm going to go up. On the far right, I'm going to go up. Now, odd multiplicity, or I just have a set of parentheses that would technically have an exponent of 1, which is odd. So at the -3, I'm going to go through the x-axis, and I'm going to try my best to kind of draw a parabola here. I have to come back up because I have to go to the origin, but that one has a bounce. So then I'm going to bounce back down, and then I know I have to come back up to go through the 4. So then I'm bouncing off the x-axis at the 0 and going back through anything that has an odd multiplicity. So even multiplicity, don't go through the x-axis. X is an odd multiplicity, you do go through the x-axis. Does anybody have any questions? Okay, now these two at the bottom, these are in standard form, so they're not in factored form. So if I'm going to identify my leading term, super easy because it's all multiplied out for me. This one would be x to the 5th. This one next to it would be -x to the 4th. So that's really quick. If you have it in standard form to identify that, that'll give you your end behavior. So this x to the 5th, that's positive and that's odd. So I know it's going to go down at the beginning and up at the end. If I have -x to the 4th for that other one, I can just immediately tell my end behavior, this is negative and even. So if it's ever even, they both go the same direction, negative goes down. The part that's tricky if it's in standard form is it's not easy to see my zeros right away because I don't know what they are because it's not factored for me. So what we got to go back and do is what we were working on yesterday and see if we can factor this. So if I've got x to the 5th minus 6x to the 4th plus 9x cubed, do those terms have anything in common? John, what do you think? Okay, if you took that out in front, what would you have left over? Perfect. Okay, so we're just going to pull out greatest common factor. Now, what is left in the parentheses? We're going to see if we can factor. Can you guys think of two numbers? When you multiply them, you would get positive 9. You'd add them, you'd get negative 6. Negative 3. Now, it would be both. I'm going to write out this step. If you want to skip that, you can. There would be two of them, though. X minus 3, X minus 3. I'm going to squish those together. X minus 3 squared, that gives me an even multiplicity on that. Now, my zeros, I'm just going to have 2 here. 0. The multiplicity on that, though, is 3. So that's going to go through the x-axis. And I have positive 3. That has a multiplicity of 2. So the multiplicity being even means I'm going to have a bounce on the 3. So I'm going to come down to my graph here real quick. 0 and 3. I'm going to go ahead and sketch in a little circle around the 3 so I know to bounce there. Just do that for myself. You don't have to do that. And I'm going to put in my end behavior. So should go down on the left and then up on the right. Now all you got to do, honest, I should go through the origin here. I got to come back down and touch the 3, but I would bounce back up, but I've got my end behavior already in there, so that's going to force my graph to be correct. Not too much going on there. Anytime it's odd for the degree, the ends of it should go opposite directions. Now, I have one more, and this is really tricky. So I have y equals negative x to the 4th plus 16x squared. Does anybody know what would make it easier to factor? I'm gonna have to factor twice, kind of like I did on that last question. Does anybody know what you should take out as your greatest common factor? Yes. Okay. I'm gonna take out basically whatever's left in my parentheses. I would love for it to start with a positive coefficient, so that way it's easier to factor. So I want to take out a -1. You can always do that. Just take a -1, and we're going to take an x squared. If I do that, left over, I have positive x squared, and that's just going to switch the sign, -16. Whatever's left over, we're going to keep trying to factor, so we want that first term to be positive. If we can do that, that's going to happen here. Can you guys think of two numbers that multiply to get you -16 but add to get you 0? Yes, -4 and +4. Okay, so not a multiplicity on those. They're just one's +4, one's -4. When we took that negative x squared out in front, though, that ends up being, this has a multiplicity of 2. So that's squared. So there will be a bounce on the 0. The other two are going to be 4 and -4, and we won't have a bounce. Those should both go through. So let's do -4, 0, 4. And if you want to, I always just, if I have an even multiplicity, which I do on the 0, I just circle it so I don't forget that I got to bounce back off the x-axis, don't go through the x-axis. Now my end behavior here should go down on both ends of this to negative infinity. And for the -4, I'm going to go through, but I got to come back down and I've got to touch the origin. I'm going to bounce because that 0 had a multiplicity of 2, so I'm going to bounce back, kind of try your best to kind of make it look like a parabola if you can when you bounce. And then I got to come back down and I go through the 4.